All right, so this week we're going to talk about rate law and determining the rate order. Now, this concept isn't actually part of the curriculum anymore. However, I am going to quickly go over it, show you the relevant sections in the textbook, and then we'll move on to equilibrium. So this week we'll have two notes. This one on rate law, which you can go over. You need to be familiar with it because it is going to be covered first year chemistry. So if you're planning on going on, it's important that you are familiar with this stuff. So let's go through it at least. I'm not going to do any quizzes or anything like that on it, but you really should be familiar with it. So the rate law is simply an equation that relates the rate of reaction to how the concentrations of the reactants change over time. In other words, how quickly the reactants are used up. It generally takes the form of looking at the concentration. So when you see square brackets like this, so the square bracket here of X and the square bracket of Y, those square brackets simply mean the concentration of. You'll notice that they're raised to some sort of a power, and that power is really only determined experimentally. So you actually have to perform a chemical reaction experiment, measure how a particular reactant changes over a period of time, and then you'll be able to figure out what the rate order is. All right, so now the constant here, because this is a proportionality, this is our little alpha here. The K value then takes care of that proportionality. That's your proportionality constant, and simply makes it into a reaction equation. Now, also one of the reasons that I want to go over this rate law idea is because it is related to equilibrium and helps us make more sense out of the equilibrium stuff. Okay, I already mentioned the exponents can only be determined empirically. You have to carry out a chemical reaction in order to figure that out. Okay. Sometimes they're related to the exponents, or sorry, the coefficients of the reaction equation, but not always. Okay. Now, determining the rate order. Okay, so if we have, let's say, this reaction between nitrogen monoxide and hydrogen that forms nitrogen and water, you will notice that I've got here some data that relates how these concentration changes affect the rate. So looking first of all at how the NO changes when you double it, the rate actually changes by a factor of not 2 but 4. All right. When you triple it, it goes up by a factor of not 4 or 5, it goes up by a factor of 9. And so that tells us that this is actually a second order, because 4 is 2 squared and 9 is 3 squared, right? So that's how these sorts of things are determined. If I look at how hydrogen changes, if I double the concentration of hydrogen, I simply double the rate. If I triple the concentration of hydrogen, I triple the rate. And so that's a first order type of reaction. All right, so that means I can determine my rate order based on these exponents now. All right, and so my rate law then is going to be rate is equal to the constant, whatever it happens to be, times the concentration of nitrogen monoxide squared times the concentration of hydrogen. Okay. All right, so the overall rate order then is third order. Okay, so simply add the exponents. There are some weird cases where you look at the reaction rate and it's always the same, and so then it really has no effect. So that you change the concentrations, it doesn't matter, and so that's a zero rate order. Okay, here's another example. So if we look at how, let's say, the concentration of IO3, if we double that, then what happens to our rate? It doubles as well. If I, let's say, double my, let's look at these ones, the first one and the fourth one. So for the hydrogen, if I double the rate, okay, it actually is a third order here. Okay, this goes up by a factor of 2 to 3. And then this one here, if I triple this, I also triple this. And so then, yeah, going from here to here, so that triples this. So that's a first order as well. All right, so I'll let you write down the rate law for that one. Again, the pertinent sections in your textbook, looking through chapter 6.1. I'd also like you to have a look at 6.2. It was really covered, 6.2 was really covered in the previous lecture on mechanisms. And so that stuff there with the potential energy diagrams, you can have a look at that. Okay, so that's this very short note. We will start equilibrium with the next one.